Jesus. Okay, we're simplifying radicals and complex numbers. Just a reminder, this symbol is also called a radical. So the square root symbol is a radical. Okay, and it says, what do we need to know? So what we need to know is that if I take the square root of 16, I can rewrite that as the square root of 4 times 4. Okay, and then I can rewrite that as 4 squared. Well, what does a square root do to a squared? Cancels. This cancels that, and I'm left with 4. Okay, so when we do our factor tree, we know that it's 4 and 4, and I circled both, but you see how only one came out? It's because the square root canceled the squared, the double, okay? So knowing that, we're going to look at number 1. We're doing our factor trees. Okay, I always start with 2 because it keeps it in flow. If 2 doesn't go into it, then I'll try 3. 3 doesn't go into it, I won't do 4 because 4 is 2, you know what I mean? I'll go to 5. I just keep going up my prime numbers. Okay, so knowing that, we don't really need that for this one. So 2 goes into it. Well, I just divide it in half. What's half of 80? 40. What's half of 40? What's half of 20?
10.
What's half of 10?
5.
Is 5 prime?
Yeah.
So we're done. Okay, now I want you to realize we are not looking at the 10, the 20, or the 40, or the 80 anymore. Why not? Because didn't we break them apart?
Yeah.
Yeah, if it's the only numbers we're looking at are the ones on the end of a branch, because we call this a factor tree, so they're the ones at the end. Okay? So knowing that, we have a pair. We have a pair. Now, I'm looking for something that matches twice, because this is a square root. Okay? We're not doing cube roots or fourth roots or any of that, so we're just looking for things that match twice. If it matches 3 times, we still only circle 2 of them. Okay? Now, knowing that, I get to take out a 2. What I'm circling is what I get to take out. I get to take out another 2, and then what did I have left over? A 5. This was left over with no pair. The reason that works is because this is the same thing as saying 2 squared. Well, the square root cancels the square. That's why just a single 2 came out. Same concept, which you don't have to show this part every time. Single 2 came out. Well, what's 2 times 2? So I have 4 square root of 5. Now, you can check these in your calculator. You'll type what was given to you, so the square root of 80. And it gives you this ugly decimal. And then I can do 4 square root of 5, and it gives you the same ugly decimal. Okay? What I want you to realize, though, is if you don't simplify it all the way, but you simplify it halfway, like if you would have stopped right here, you would have had a set of 2, and you would have had 20 left over, and you still get the same decimal. So just be careful. It doesn't always mean you simplified it all the way, but it means you're on the right track. Okay? So that's how you can check your work. Let's look at number 2. So again, it's an even number, so I know 2 goes into it. What's half of 288? 144. What do we know about 144? It's a perfect square. If I can make these match, yes, 12 and 12 are not prime. But since they match, I can stop. And as long as all the other numbers are prime, I'm good. Well, here's prime, and we're not looking here or here because we broke those apart. So is 2 prime? Yeah, so what did I circle? 12, and what was left over? 2. Any questions with that? You can stop when they match, or when it's prime. Okay, so technically if you would have kept going, you could have done 2 and 72, and you would have gone all the way down, and you would have just multiplied like 2 times 2 times 3, okay, and you'd still have gotten 12 square root of 2. So just know it still would have worked, it just would have been a lot more steps. So if you don't notice it's a perfect square, that's fine, you can keep going. Okay, look at number 3. This is a fraction. I want you to realize fractions we can separate. Now, before we would separate, though, we want to make sure they don't simplify. Does 8 over 25 simplify? No, so we don't have to worry about that. So we just go ahead and separate. So I'm going to start on the top. I'm going to break down 8. So that's 2 and 4, 2 and 2. So I have a pair of 2s. And then what do I have left over? 2. So I take out a 2, and there's a 2 left inside. What about 25? Well, it's 5 and 5. Don't those match? Yeah, so it's a perfect square. Did I have anything left over? Therefore, there is no more house. Do not put the radical back. Okay, it's just 5. So knowing that, does 2 over 5 simplify? So here's your answer. Now, if you would have gotten like 2 square root of 2 over 4, does 2 over 4 simplify? Yeah. So you would have simplified the outside. Never the inside, only the outside. Does that make sense? Yeah. So this would have gone to 1 square root of 2 over 2, which you didn't even have to put the 1. It could just be square root of 2 over 2. So just know that if you have something that simplifies, you do have to simplify. Okay. Okay, so look at number 4. Okay, on number 4, I already have a -5 there, so I'm going to rewrite that -5 over here so I don't forget about it. And there's no symbol in the middle, so I'm multiplying. So I'm going to break down 32. What goes into 32? Start with a small prime number. 2 and 16. And then isn't 16 a perfect square? Yeah, what times what gives you 16? 4 and 4. Because they match, we can stop. Okay, and knowing that, what am I taking out? 4. And what's going back in the house? 2. But I can simplify this. What's -5 times 4? -20. Any questions with that? Okay, so look at number 5. Now, number 5 tells you, it has this bubble. It says I is the same thing as the square root of -1. But I want to remind you of when you were in Algebra 2. I remember you would graph something, and then you would be told to graph the opposite of that. Do you remember that?
Yeah.
Okay.
Inverse.
So the inverse. So the inverse of this is the square root of x, the opposite. However, do you notice that they don't match perfectly? Like, it's supposed to be a reflection across the diagonal, but only half of it reflected, and it's because the other half is your imaginary numbers. Okay? Because you can't take the square root of a negative, so that side disappears. But that's where that I comes into play. Those are your imaginary numbers. Okay, so knowing that, because I have a negative on the inside, I have to take out an I. So I go ahead and make it positive, and I put an I outside for my answer. Well, what's the square root of 81? It's just 9, so we have 9i. And even if you were to have tried to type this in the calculator, if you try to do -81, it tells you non-real answer because it's imaginary. Okay, so if you ever get that, it says non-real answer, know that you have to take out an I, and then you can retype it without the negative, and you get 9, so just know that you have to put 9i. Mm-hmm. Okay, so look at number 6. This is setting you up for when we do quadratic formula. We're not there yet, but this helps simplifying and knowing how to simplify now. So when I notice that these will simplify, like 10 over 5 simplifies, right? I'm going to go ahead and separate. So I have 10 over 5 plus or minus. Well, I have to break that down first, but I'm going to have a 5 as a denominator still. So, well, I know it's negative, so I'm going to make it positive and put an I. And I'm going to break down 28. So what goes into 28? Start with your smallest prime number. Does 2 go into it? How many times? Does 2 go into 14? 7 times. 7 is prime, so we're done. Okay, so I have a pair of 2's and I have a 7 left over. So my pair comes out in front, and my root 7, my radical 7, goes after the I. So this is the proper way to write that. Now, are these like terms? No. To be a like term, this has to also be imaginary, and it also has to have a radical 7, root 7. It doesn't have that, so these are not like terms. So these cannot simplify together. I cannot add or subtract these. But I can simplify my fraction. So 10 over 5 simplifies to 2. 2 over 5 doesn't simplify, so this stays 2I root 7 over 5. However, this is two answers. It has a plus and a minus, so we have to write it as both. I always start with minus, but it doesn't technically matter. So there's your answer. Well, it has both. See how it has a plus and a minus? So it's plus and minus, plus and minus. That's why I wrote once with a minus, once with a plus, because it's technically twice. Okay, last one. Look at number 7. So I know 9 over 4 doesn't simplify, so I'm going to go ahead and keep this as a single fraction, which is fine. If I think it simplifies later, can I separate it later? Yes. So I have 9 plus or minus, but what do I know about the square root of 25? It just equals 5 with no house because it's 5 and 5, which didn't have a leftover. Well, knowing that, I can simplify this. And I don't even have to separate to simplify the denominator. Good Lord. Okay, but I can rewrite it once with plus and once with minus. Well, what's 9 plus 5? 14.
14, sorry.
Okay, and does 14 over 4 simplify? Well, they're both even. So we can start with half. What's half of 14? 7. And what's half of 4?
2.
Does 7 over 2 simplify?
No.
No, 7's prime, so we're done. So there's one of your answers. Here, what's 9 minus 5? So I'm left with 4 over 4. And what's 4 over 4? 1. There's my two answers. So least to greatest, 1 is actually smaller because 7 divided by 2 is 3.5. So there's your answer. Now, there are a lot of practice problems, but you have plenty of time between today and tomorrow. So if you finish the front today, you can stop. However, I do want to talk about number 19. So on number 19, I have 3 plus the square root of 108. So first things first, I'm going to separate 108. I know 2 can go into that 54 times. I know 2 goes into 54 27 times. But I know 2 doesn't go into 27, but 3 does 9 times, and then 3 and 3. So there's all my prime factors. I'm going to go ahead and rewrite my 3 plus here so I don't forget about it. And I know I have a pair of 2's and a pair of 3's with what left over? 3. What's 2 times 3?
6.
Square root of what?
3.
Can I simplify this?
Yes, you can. No.
No, why not?
Because you gotta add.
They are not like terms. 3 does not have a root 3, therefore they cannot combine. So that's my answer. To be like terms, you would have had to have 3 root 3 plus 6 root 3, and then you would have gotten 9 root 3. That's what like terms looks like. Is that what we have?
No.
No, that's why we couldn't combine. Does that make sense?
Yes.
Okay, so just a refresher on that. If you have questions, what should you do?
Ask.
Ask.